Hello everyone, this is R.Soundaria, Assistant Professor, Department of Mathematics, Kaveri College for Women, Trichy. Set theory is a branch of mathematical logic that studies sets. It is described as collection of objects. Although objects of any kind can be collected into a set. So the modern study of set theory was initiated by the German mathematicians Richard Dedekind and George Counter in the year 1870. In particular, George Counter is commonly considered the founder of set theory. So the non-formalized system investigated during this early stage go under the name of Navy set theory. Now let us consider set of all shapes. So set of all even numbers. These are the examples of sets. So set is a collection of objects and it is represented in curly braces. The set is represented by the capital letter. For example, A equal to 1, 2, 3, 4, 5, etc. 9. So, A is the set and 1, 2, 3, 4, 5, these are elements or we can call these are members of the set. So, the elements are written in the set can be in any order but cannot be repeated. So, all the set elements are represented in small letter in case of alphabets. For example, 1 belongs to A, 2 belongs to A, etc. So the cardinal number of the corresponding set is 9. So number of elements in the set. Next, let us consider how we can use set diagram. So this is a number set diagram as shown in the diagram. Representation of sets can be written in set builder form and roster form. So what is set builder form? Set is represented by using statements depicting relation among its elements. What is roster form? Set is represented by listing its elements in braces. Next, let us consider the descriptive form and set builder form, roster form. So for example, the set of all vowels in English alphabets. This is like a descriptive form. So how we can write in the set builder form? X such that X is a vowel in the English alphabet. And roster form, we can write it as A, E, I, O, U. Like that, the other examples also we can do. Next, let us consider type of sets. The first one is empty set. The second one is singleton set. Third one is finite set. And fourth one is infinite set. And fifth one is equal sets. And sixth one is equivalent sets. And seventh one is universal set. And eighth one is subset. And ninth one is proper subset. And 10th one is superset, and 11th one is proper superset, and 12th one is power set. Now, what is empty set? So, empty set is nothing but null set, or we can call it as phi. For example, the set of apples in the basket of grapes is an example of an empty set because in a grapes basket, there are no apples present. Next, let us consider singleton set. So the set which contains a single element is called a singleton set. Next, let us consider finite set. So the set which consists of a definite number of elements is called a finite set. For example, A equal to 1, 2, 3, 4, 5 like that. So this is the diagrammatic representation. Next, we consider infinite set. A set which is not finite is called an infinite set. For example, natural numbers, whole numbers as well as integers. Next, let us consider equal sets. So, two sets A and B are said to be equal if they have exactly the same elements. The order of elements don't matter. For example, A equal to A, B, C, D and B equal to B, C, A, D. Here, the order actually doesn't matter. Next, let us consider equivalent sets. So, if the number of elements is the same for two different sets, then they are called equivalent sets. For example, N of A equal to N of B. Let us consider universal set. A set which contains all the sets relevant to a certain condition is called the universal set. It is a set of all possible values. For example, A equal to 2, 4, 6, 7, 9, B equal to 2, 3, 4, 5. Then universal set here we can write it as like this. So union equal to set of all the numbers. Next, let us consider subsets. A set A is said to be subset of B if every element of A is also an element of B and it is denoted by A contains B. Even the null set is considered to be the subset of another set. In general, a subset is a part of another set. So this is the example as shown. Next, let us consider proper subset. So proper subset of B, and it can be written as A is a subset of B. Here A is not equal to B. So this is the example we have shown. Next, let us consider superset. So a set is said to be a superset of B if all the elements of set B are elements of the set A. So it is represented as A contained in B. Next, let us consider proper superset. A proper superset of a set A is a superset of A that is not equal to A. We can see some examples of proper superset. Next, let us consider power set. A power set is a set or group of all subsets for any given set, including the empty set indicated by null set or phi. So this is the example we shown. Thank you for watching. I hope you have understood. Thank you for watching.